Hey guys, happy Thursday. I hope you spent your Wednesday doing some iReady testing. Today we're starting our new unit. This is going to be a short mini unit kind of launching us into chemical reactions. So today is this October 1st. Our title today is Atoms in Molecules. So I want you to think about today, what is a water molecule actually made of? What did it actually look like? And I don't mean like, oh, it looks like a little ping pong ball, Mr. Murphy. That's what we've been thinking of it as. And because we can understand why water does some of the things it does, like freeze or evaporate, if we think about it as a little ping pong ball that is just bouncing around. But is that really what it is, or do you think it might be more than that? Does it have parts to it, or is it just one piece? So I want you to tell me, what do you already know? What you might think is true about what water is made of, what it might look like. Pause. Try to answer these questions the best you can. Come on back. We'll keep going. We have a lot to do. I have a scientist of the day. I have a learning target. I have some vocabulary. That's before we get to the breakout rooms. I'll go over those with you. And then finally, we have some practice slides and an exit ticket. So our scientist of the day is Denit Peleg, I think. I don't know how to pronounce her name correctly, probably. She is an Israeli fashion designer. She's so cool. Okay, so she studied engineering and design. And she wanted to be a fashion designer, but she's like really into engineering. She's like, what should I do? I know I should design new clothes and then 3D print them. So she can use her like engineering, having to like engineer a 3D printer that works this way, and also using her design skills and make clothes using 3D printers, which is super cool. So here is the actual 3D printer that she uses, and I don't know who she's looking at, but she's talking about how to design different clothes. Here is a simple design of one. So you actually have to build this in a computer. It's a 3D model, a model, just like we talk about models of particles. You're making a model of what this is going to look like, and then the printer prints it out for you. And here's some other models. Hey, a different kind of model, modeling clothes, different than a science model. This is just another example of I want you to know, hey, are you into fashion? Great. That doesn't mean you can't be a scientist. Be a scientist, think like a scientist, engineer things, learn how to build something, design it, engineer it. But we're not talking about an airplane or a spaceship. We're talking about clothes, which is maybe something that a lot of you guys think are important. So I just thought this was a really cool example of science put to a different use than maybe you're used to. Today, here's our new standard. We're going to develop models to describe the atomic composition of simple molecules and extended structures. Okay, so today's learning target specifically, we're talking about describing the atomic composition of simple molecules. So when I say composition, I mean the parts that make up the whole. When I ask you about the what something is composed of, that means what is its composition? What are the parts? What things go into this? So, for example, I can ask you here. I move myself out of the way here. What is this lunch composed of? You might say, oh, the lunch is composed of carrots and tomatoes and different fruits and a sandwich and milk. Those are the different parts that make up the lunch. Okay, so today we're looking at parts that compose the whole. Okay, so we're asking ourselves this question: what are molecules made of? And it turns out we've been oversimplifying this idea of molecules or particles. They're not simple circles. They can actually be really different sizes and shapes. For example, there's a water molecule. That's a benzene ring. There is methane, I think. Propane. This is propane. I think that is this big long thing down here, I think is nylon, like your clothes might be made out of nylon. This is a protein. I think this is a hemoglobin. This is a protein in your body is just a big molecule, which is so cool. You can see these are so different in size and shape. This isn't to scale. Look, these balls should all be about the same size. So this thing, each of these little tiny circles should be the same size as these, but I can't fit them all on the screen that way. But molecules can be really, really different. And this unit right now is us looking at the different types of molecules there can be and how they're different from each other, which is super fun. Okay, so today we're talking about simple molecules. Those are smallish groups of atoms bonded together. And a molecule just generally is the smallest piece of a substance that has all the properties of that substance. For example, water molecules are the smallest piece of water that you could still call water. If you took this water molecule and broke it down any smaller, you don't have water anymore. You have different things. Okay, so we're looking at simple molecules, relatively small groups of particles like this. You can count them 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so an atom, I said up here, that molecules are groups of atoms. An atom is a tiny particle. And it's the building block of all matter. Okay, atoms can be combined to form molecules. I love this analogy. I use it all the time. If molecules were words, then atoms are the letters. Let me say that again. So molecules are like words. A word, like pick any word on here. This word right here, tiny. It is made up of 4 different letters. The atoms are like the letters. You put atoms together and you make words, just like you make letters together to make words. You put atoms together to make molecules. Sometimes, like the word all, you have 1 A and 2 L. So you might use 2 of the same letter. You might use 2 of the same atom in a molecule. Okay, an element is a type of atom or a substance made of only 1 type of atom. So there's actually 2 kind of different ways we use the word element. Most of the time when I'm talking about it, I'm saying a type of atom. So which elements are in the periodic table? They are all there. They're all examples of atoms, but each symbol is its own element. Each type of atom is an element. We'll get more practice with this in a little bit. You might want to come back to this slide later. Okay, so in breakout rooms, I'm assuming if you're here, you missed the live class. So in breakout rooms, we are working on these next 2 slides. Let me come out of the thing here. I'll show you what we did. I'm just going to start it. You guys will have to finish it on your own. Here, let me see. How can I drag this down, make this a little bit bigger for you? Or maybe I can't. Of course I can. All right. So 1, leave the pictures. Leave the pictures. 2, match one of these black cards, and they're just in a stack here. They're like, if you were in my classroom, I'd give you paper and you'd move them around all your desk. You're not in my classroom. We have a slide here. Your job is to organize the cards, starting down here with these black outlined cards, and then the blue outlined cards. So you're going to make a row like this. Here is one thing that is 1 atom. It is helium. Okay, so I'm looking for something with 4 atoms. I'm looking around trying to figure out which one of these has 4 atoms. 1, 2, 3, 4. I think this one has 4 atoms. Which one has 24? Which one has 55? Which one has 3? Your job is to put all of these together. Then you're going to come back over here. These are pictures of molecules. These are the number of atoms in each one. And then these are what we call the chemical formula of a molecule. You might have heard of like H2O. H2O is the chemical formula of water. It tells you the atomic composition, basically. It tells you what atoms the molecule is made from. So I'm trying not to give you all the information, so I want you to start exploring. One of these matches one of these pictures. There's 7. So play around with it. See if you can figure out which one. Maybe these are easier. I have you start with the black ones because they're easier. Then go to the blue ones, figure out which one matches that. So in the end, you're going to get black card, black card, black card, black card, and then below blue card, just like this. So you're going to have a row of pictures like you have here. You're going to have a row of black cards. You're going to have a row of blue outline cards. Okay, then once you get that done, I don't expect that to take more than a couple minutes. Then I want you to try to answer some of these questions, as many as you can, and we'll go over them together. Or we did go over these together, but I will create a slide that kind of outlines what we come up with, and we can use that. But this is the thinking today is how do we represent atoms in a molecule? How do we represent different elements? How do we show atoms are connected to each other? How do we write a chemical formula? What are the rules for that? And then is there anything else you could figure out about specifically different types of atoms? How do we model them, etc.? In what we're trying to do is use that slide above, that card sort, to help us figure out rules for how scientists, and therefore us as well, will model atoms and molecules. Because I want you to learn the skills that you will see anywhere, no matter what science class you go into, or even if you're like reading a newspaper article, they might drop, chemical formula on you. They might talk about atoms and atomic structures, even if you're just talking about painting something or medical things like trying to understand COVID-19 or gases in the atmosphere and why some pollutants are worse than others. There's all kinds of information that even if you're not doing science, you need to understand how to use this type of model and understand it and maybe even do it your own self. And so that's what we're focusing on. Okay, so I'm going to go back into present mode and I'm going to show you what your independent work is today. Okay, so there's kind of three parts. There's slide 14 and 15, which is just a periodic table and a common elements page, and I'll show you those. And then 16 through 19 have practice molecules. You're going to type the answers right onto the slide. And then slide 20 has your exit ticket. Okay, so this is a periodic table. If you were in my classroom, I'd print it off and I'd have it on your table for you, but I don't have that for you. So later, I'm gonna ask you questions. You have to come back and look at this. You can also Google periodic tables. There's an interactive one I've linked for you. So they're just everywhere. It's a really, really easy thing to find. Probably easier on your computer than it would be in the classroom. But I want you to see that each of these boxes is an element, a type of atom. They have numbers. They have different numbers. The number at the top, as you can see here, is this example. The number at the top is the atomic number. It is the number of protons. You don't really need to know what that means. We're not going to learn about that. But it's also like the order that they're in. So if you notice, if you read this left to right, there goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the bottom left, and then across, and they have these weird gaps. And again, you don't really, I can't easily explain to you why those gaps exist until you get to maybe high school chemistry. But you can essentially read it from top left to right, left to right, left to right, each row. Okay, and eventually we'll get down. I think this year we'll get down to talk about the mass. That's actually how big the element are. It's actually a different size. They weigh different amounts. So this one weighs 1, and this one weighs 122. It's 122 times bigger than this one. So it's actually really big difference in their size. But for today, I just want you to look for the symbol. The symbol is what we call like the letters. Sometimes they're one letter, like carbon has 1. But sometimes they're 2, like what's a cool one that I didn't ask you about? Ooh, tin. Tin, like the metal tin, is actually SN. Notice that the first letter is always capital. And the second letter is always lowercase. That's important because if I ask you big C, big O, you know there's a carbon and an oxygen. But if I ask you big C, little o, cobalt. So it actually is very important that the first letter is always a big letter, capital, minuscula. The second letter is always a lowercase letter, a small one, minuscula. I learned that those Spanish words specifically as I was teaching this, and I want to have kids remember capital, lowercase letters. Okay, keep going. So in this class, there are some common elements you're going to need to know. I'll give you 4 that I'm like, you have to know these. If I show you an atomic symbol H, an H in a circle, you know what that is. If I show you a carbon, a C in a circle, you have to know what that means. An O in a circle, you know it's oxygen. An N in a circle, you know it's nitrogen. Those are at least 4 very common elements. They're common in organic matter. So it means like these 4 elements are like what you're made of. Almost 100%. Very little other things. There's some sulfur in you and some calcium and other things. But almost all of you are made of these 4 things, okay? And so you just need to know that what C is carbon. I'm only going to make you memorize 4. Otherwise, and actually, you can always look them up on the periodic table. The periodic table will always be available for you. And that's true up through like college chemistry. You don't need to memorize the periodic table. You never have to. It's always there because we don't want to memorize it. We want to go and check to see the information. Okay, so real quick, here's the molecule of hydrogen peroxide, something you might have under your sink, go with sink, in the cabinet. Keep it in the dark, and you might wipe your cuts with it. It is this is the picture of it, of one molecule of hydrogen peroxide. I want you to think about how many atoms are in this molecule? How many elements are in it? Remember the difference between atoms and elements? If not, go up to the other slide and look. What elements are in this molecule? For each of those, see if you can come up with the right answer, and then drag this across. This little box is covering the answer. The answer is under here. Drag it to check yourself. I just want, so this is like the example, the test one. I want you to have the answer. I'm not giving you the answer on these other couple, okay? This molecule is called ammonia. How many atoms is it made of? What elements are in it? Here's a link to the periodic table, or you can go up and use the one above. I want to know, what are the atomic symbols for potassium, silver, copper? Put the symbol in here. Remember, those are the letters that we use to shorten version of it. What is the name of the element with the following symbol? And I can't see it because I'm in present mode, but there's S. What is the name of that, of an S? Of an S. S is the symbol. What's the element? You're going to write out the full name. Fe is a element. What's the name? Cl. This is a lowercase l. It trips up kids every year, and it will trip you up, I promise. But this is a big C and a little l. Find it. What is the name of that element? Okay, last practice. Which of these is a picture of ozone? O3. Is it A, B, C, or D? Put A, B, C, or D here, and then tell me why you picked that one. Then go into your exit ticket. It's similar questions to these. These are just practices. I'm not going to keep a good eye on what you guys do here, but I will look at your exit ticket to know how you guys did. As of right now, I'm not planning to grade your exit ticket, but I might. So take your time, do it right. That's it. Tomorrow we'll learn more about atomic composition. We'll talk more about this stuff. We'll do a little bit more practice. We'll take a little quizzy quiz next week about it. I'm done. Thanks, guys. Have a good day.